many, so I'm in a cardiac muscle cell here, under optimal conditions. How many NADHs am I starting with? 10. And how many FADH2s? 2. So you see where I got these? I got these from both glycolysis and the citric acid cycle, and I got these two from the citric acid cycle. If I'm under optimal conditions, which I am right here, how many ATPs does each one of these represent? 10 is 10 times what? 3, because it's optimal condition. So that's 30 ATP. Right? 2 times 2, so that's 4 ATP. So what is my total ATP production per glucose here? 30 plus 4 plus 2 plus 2, which is 38. Okay, you're right with that? So when I say I get 38 ATPs maximally, I got to be under theoretically optimal conditions, and I have to be only in a hepatocyte or a cardiac muscle cell. Because what would happen if I was under optimal conditions and I'm in a typical cell in the body? How many NADHs do I have? The only thing we got to worry about is this here. There. So I still have I don't have to worry, I've got my 8 NADHs from the mitochondria because they're made in the mitochondria. But these two are out in the cytoplasm, right? And in every cell in the body, except these two, I can't bring those electrons in as NADH. I have to bring them in as FADH. So I give them to FADH. NADH gets oxidized, FAD gets reduced. Now I can take them into the mitochondria. But in the mitochondria, now that still only gives me those 8 NADHs, right? Make sense? How many FADH do I have now? I have 4. Does everybody see where I got 4? 2 that are made here. These 2 in the cytoplasm can't come in, so I change them into FADH and bring them in. So now I have 8 NADHs, 2 FADHs, turn those into 2 FADHs, I have 4. So now do the math. What's my ATP here? 8 times, we're still under optimal conditions. So that's 3 per NADH, so that's 24. Now what's this number? 8. So that's 24 plus 8 is 32, plus 2 is 34, plus 2 is 36. So this would be, how many ATP here? 36 ATP. So you will see, and I think Carlo actually said this before, is that if you talk about, you see this number all over the place. If you talk about, oh, per molecule of glucose, how many ATP can you produce? They'll say 36 to 38. Why is it 36 to 38? Well, it depends on, obviously we're assuming it's optimal conditions, but are you in these cells that have the ability to use the cytoplasmic NADH, or are you in these cells that have to take cytoplasmic NADH and convert to FAD? Yes?
Wouldn't it be 32?